Hey everyone, this is David, ACS Bridge Fellow, General Fellow, founder of the Biochemistry company. And one of the things we're doing today is we're going to go through an explanation of the central dogma, going through DNA, mRNA codons, and then the amino acids that make up proteins. So, central dogma and its significance as it relates to metabolism. The central dogma, DNA. Let's go through the DNA. So, DNA is made up of nucleobases. So we have adenine. So we draw it, and we're going to use Watson-Crick base pairing. This is adenine. We draw the ribose. We put the phosphate there. And then we use our little hydrogen bonds. We attach it to hydrogen bond to thymine, which is a methylated uracil. And we have it. And then we have the phosphate. And then from there we have this, which is another component. And we're drawing guanosine. And moving it right along. Of course, it's a little smushed, but we have this. So let me just adjust this. If we move the phosphate, put it like this. Do it like this. And like this. So, and we have our double bond there. This is a cytidine. Cytidine, triple hydrogen bonds, two hydrogen bonds between adenine and thymidine, and guanidine and cytidine, and we have DNA, and it goes from 3 to 5, and 5 to 3. So we have DNA here, and we also have our hydroxyls there. So that's DNA. So the only nucleobase that we are missing in this instance is uridine, which is basically going to be appreciate bond angles, which is that, and of course you just attach the ribose and the phosphate. So this is DNA. Moving right along, let's go to RNA. And RNA, I came up with a nifty way to code the codons, the 64 codons. So from DNA to RNA. So we have the structure of DNA. Now let's work through the codons. So uracil, cytidine, uracil, cytosine, adenine, guanosine. And we go right down. So I'm using the amino acid one-letter abbreviations. F2, L2, L4, I3, start 4, V4, S4, P4, P4, A4, Y2, stop, 3, stop, 4, H2, Q2, N2, K2, D2, E2, and then moving right along, we have C2, stop, 3, W4, R4, S2, R2, G4. So what we have here are the one-letter abbreviations for all amino acids and their locations on the 64 codon chart. So writing this out, we have leucine, 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 isoleucine in those three positions. And then moving with this, we also have on this side here UCKG. So you kind of get the trend. So phenylalanine is UUU, phenylalanine UUU, phenylalanine UUC, also can be represented as UUC, and we have that from there. So keep that in mind. This is the representation using the 64 codons. So with that in our minds, you no longer have to write it. We can just go right along to the amino acids that make up protein. This is essentially what that's in this canonical way. So we just put this on the side here. We just put this on the side here, and we'll use it as we go through the amino acids. So with the amino acids, we have non-polar. So gavyl, pro, trip, methy, fen, glycine, alanine, valine, isoleucine, leucine, proline, tryptophan, methionine, and phenylalanine. So glycine, of course, the L-amino form, which amino acids are typically L-amino acid, is going to be one of my friends. Her name is Daj. So I'm like, hi Daj. The hydrogen is on the dash, and the R group is on the wedge, and then we have our carboxylate, and that's that, L-amino. So glycine. Now we're not going to draw these stereospecific. That shows us biochemistry. We're just going to draw them in planar form. That's that. Glycine. Now, one of the things we're going to do as we go through this, as we write the corresponding amino acid, we're also going to think of how it will be represented using the 64 codons. So in this instance, right there, we know from our chart that was drawn previously that glycine would be in this position right here. So glycine would be in this section of the chart. We don't have to redraw the chart because we know the chart. So glycine is going to be GGU, GGC, GGA, and GGG. In the last corner of the 64 codon chart. So that's that. Glycine, alanine. We know what alanine is. We